So 28 is just a quadratic equation. It says find the roots of the function. I think that's missed terminology. It should be the zeros of the function, which would be the roots of the equation, 3x squared plus 7x minus 2 equals 0. So we're going to find the roots or solutions to this equation. I actually prefer completing the square, but since we have an odd middle term here and we have a lead coefficient other than 1, it actually works better to use the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So a is 3, b is 7, and c is negative 2. So x equals negative 7 plus or minus the square root of 7 squared is 49 minus 4 times 3 times negative 2, all divided by 2a, which is 2 times 3. So that's negative 7 plus or minus 49. So that's negative 12 times negative 2 is positive 24. All divided by 6. 49 plus 24. So that's going to be 13. That's 5. So 73. So my final answer is going to be negative 7 plus or minus the square root of 73 all over 6. Or if they want two separate answers, negative 7 minus the square root of 73 over 6, or x equals negative 7 plus the square root of 73 all over 6. And we'll go check the answer. So negative 7 plus the square root of 73 over 6, negative 7. And they don't even stay with function. They just say roots, so they really went with an equation. So if you want just the answers, you can stop here, but I will show you how you can do this in the calculator. So we're just going to use the menu, 3 for algebra, 1 for solve, put in our equation, we're solving for x, and there are the two solutions. Now you might be wondering, how could I do this if I had complex solutions? We can try that. Menu, 3, 1, 3x squared plus 7x plus 10 equals 0, comma x. Oh, it says false, but do not fear. We have an app for that. We're going to just put a C in front of the solve, so that's complex solve. So we hit enter, and it's 7 plus or minus 71i all over 6, or this is the traditional way to show complex numbers. So x equals a plus b times I. So that concludes this video.